Okay, in this problem I've got a spherical pressure vessel. It's made of steel, has a modulus of 200 gigapascals and a Poisson's ratio of 0.3. Has a diameter of 2 meters, thickness of 10 millimeters. Okay, I've got a little strain gauge put on there, 20 meters long. It increases by 0.012 millimeters when this thing's under pressure. Okay, so from that, I want to figure out what the pressure is. Also, what is the absolute maximum shear stress? Okay, so the first thing I'm going to do is I'm basically going to find what that pressure is through the pressure. I'm going to get that relationship with the stress. Okay, so for a sphere, the stress is PR over 2T. Okay, P is what I'm trying to find. R is 1,000 millimeters, and then thickness is 10. So that stress that's occurring here is 50 times P. Okay, so that's the stress that it's under related to the P. Now, the strain gauge gives me the strain, okay, which is just going to be 0.012 over 20. So I get 0.6 times 10 to the negative third millimeters per millimeter. That's the measured strain. Now I'm going to use that generalized Hooke's law to relate these two. Okay, so what I have here is I have two, if you think about this, I've got 50p acting in two directions and 0 acting in the third direction. So that's really what I have here. I've got 50p, and 0. Okay, there's no stress in basically like the radial direction. So again, 200 gigapascals, Poisson's ratio is 0.3. I know my strain that's measured. So I take this equation, I solve for P, and I get 3.43 megapascals. So then from that, I can find the maximum stress, which is 171.43. And then from that, I can determine the absolute maximum. Okay, so again, I've got two stresses of 50, okay, and then one stress of 0. So my maximum is, well, I'm sorry, not 50p. So I have two stresses of 171 and then one stress of 0. So my maximum is 171. My minimum is 0. So the absolute maximum shear stress is 85.7 megapascals.